My name is Colin Gould, and I am currently observing in a first grade classroom.
I'm just Balderes, and I'm also observing in a first grade classroom.
Okay. And our CP1 is over, or CP2 is over MP1, the mathematical practice one, which is making sense of problems and persevering in solving them. So what is MP1? Mathematical practice 1 involves making sense of the problems and persevering in solving them. First, you have to figure out the meaning of the problem and look for a starting point to finding its solution. So you need to figure out what you're trying to find, how you're going to go about doing it. If it's an addition problem, you need to figure out that you're going to add certain things. You need to figure out what you're adding and all that kind of stuff. Then you need to analyze the information given along with the constraints and goals. This helps finding the steps to solving the problem instead of simply just guessing. If you know the information that you're given, you know your constraints, you know what your end goal is going to look like, instead of just guessing, you're able to actually formulate a problem and go towards the goal. Then you will consider changes or simplifications of the original problem to gain insight. This is kind of where if you're doing like an addition problem, you can move the numbers around to you can make a subtraction problem if that's easier for you, but there's different things you can do to the problem and still get the same answer. The right way, there's no right way to do the problem if you can get the same answer.
And then you want to check progress and change course if necessary. Okay, so basically the students are going to use a metacognitive thinking, and they are going to see if they're coming up with a reasonable answer or not, and if not, then they need to change in what they're doing. And younger students may rely on concrete objects or manipulatives or pictures, so like things like counters and hands-on stuff.
Base 10 blocks.
Base 10 blocks and all that stuff. And then more proficient students may check answers using different methods. So like if you're doing a subtraction problem, you can check with addition. If you're doing a division problem, you can check with multiplication to see if they're coming up with the right answers.
And how you would adapt for kindergarten through 6th grade. You got to talk about the facts given and the question being asked within the problem. Your students may not always know what's being asked, so that's a good way to get started with the problem. You explain every fact given, everything you're going to be using to formulate your problem, and you got to discuss why and how you would solve the problem using a certain strategy. If they're able to talk about why they would use a certain strategy, they're going to have a deeper understanding of it, and it's going to make sense to them, and they're going to be able to use it quite a bit more for different aspects. So then we would figure out which method of solving a problem is easiest for the student, and this is kind of where metacognition comes into play. You got to know how your brain works, what's the easiest way for you to do something. If you know what your strengths are, you can play into those better and use those to your advantage. So.
And then you want to give example problems and model problem-solving process while asking meaningful questions. So you just don't want to give them a new problem and expect them to know how to do it. You want to take them through the process and then ask questions like, well, why am I doing this? Why do you think I would choose subtraction for this problem? To get their minds thinking. And then you want to monitor students' progress and understanding. You want to make sure that they're following along and that they're grasping the concepts, because if not, you probably need to go back and reteach it and maybe show them a different way of approaching the problem. And then you want to celebrate successes and efforts. They might not get the whole problem right, but they might have been on the right track, and you want to praise them for anything that they're doing.
And this is implementing the SIOP methods. So not all of your students are going to be very fluent in English. A lot of them come from different backgrounds, so you have to understand, how you word problems is going to be important to their understanding of those problems. So you use clear language and content objectives written visibly in front of class. So having things written up clearly and not being too wordy about it, just making it clear and concise, that's the best way for them to see that. Allow for manipulatives and visuals for all students. Again, we talked about visual or manipulatives earlier, but it's really helpful with students that don't speak the language as well. It helps them to see something visually. Then we have use appropriate proficiency levels for all students, even ELL. So you want to put, again, words that they're going to understand. You want to give them problems that they're going to be able to actually accomplish. You don't want to give them stuff that's going to be too hard for them to do.
And students should be engaged for the majority of the class time. So basically, you don't want to be up there just talking the whole time or just trying to drill them with facts. You want to give them chances to talk with their groups for like collaborative learning. You want to give them a chance to use manipulatives and times to really process what they're doing instead of just talking in front of the class the whole time.
Then we're using scaffolding models to make sure that like ELL students are ready to move on to a higher level. So before they can move on to one level, they have to be done and actually know about the things that they are supposed to know to move on to the next level. If they don't know how to do repeated addition, they're not going to know how to do multiplication. They have to know that level to move on to the next level. It's kind of what scaffolding is.
And then you want to use collaborative learning, as mentioned before. You want to give them times to work as a group or with partners so they're able to discuss what they're doing. So it gives them another way of processing the information that they're taking in. For our first grade math problem, we have Johnny has $5. He wants to buy soda from the store. The soda costs $1.49. How much change will Johnny get back from the cashier? So the student would look at this problem and they would think that they are wanting to buy something. So when you buy something, you have to give your money away. So you are subtracting. And so you would take $5 and you would minus $1.49, and then you would get the answer D, $3.51. And then they could go through and check that by using the addition as well.
And our higher level math problem, it says out of a group of 200 high school students, 36 are taking calculus, 52 are taking physics, and 126 are taking neither calculus nor physics. If you choose one of the 200 students at random, what is the probability that the student chosen will be taking calculus but not physics? And this is a little bit harder, so what you want to figure out first is what your answer is going to look like. So you have your 4 answers, so obviously it's going to be in a percentage-wise. And your constraints are it has to be within 0 to 100%. And what I would do first is since what we're trying to figure out if what the probability of the student taking calculus, so it's going to be one of the students that's taking either calculus or physics. So we want to get rid of the 126 students that are taking neither of those things. So right off the bat, we can subtract 200 minus 126, and we get 74 students. And then it says there are 52 students taking physics. So we want our student not to be taking physics. So we can subtract out of that 74, we can subtract 52 students. So we get 74 minus 52 is 22. And that is our students. There's 22 possible students out of the 200 that are taking calculus. So if we want to find a percentage, we just take, batteries low. We take 22 divided by 200, and we get 11%. And that makes our answer be 11%. And basically that's our MP1 and how to use it. And these are our sources. And that's how we use it in our grades that we're in right now, and actually our level as well. So that's it.
Thank you.